Okay, so again, I'm reiterating what was the problem statement. The problem statement was one that instead of these point charges, if I replace by an infinite line of charge parallel to z-axis, the first thing that I'm interested in was in finding the potential. So I found potential due to an infinite line of charge, and I got the result as lambda upon 4 pi epsilon naught ln of r naught square upon r square, where r is the distance from the infinite line of charge. And further, I also stated that I'm interested in finding the potential as a function of x, y, and that is because you see this is infinitely extending. So along z-axis, one that it will be very difficult to say because see all these like infinite line of charge right now is at, let's say, it is here you have this z coordinate as 0, but uh, if you put a line, then it will be a problem. Like if you even put this particular this point at in 3 dimensions, then because this is infinitely extending, so how to assess the distance? मतलब इसको कैसे हम मतलब, let's say if I'm placing it at a distance z, and are you getting my point? So मतलब ये z मतलब हवा में होगा ना, समझो, in 3 dimensions, and this is also going in 3 dimension, but it is infinitely extending. So how to take the distance? How to take the distance? So that will be a problem because this is infinitely extending. So one that is the case, and also another case you can see that I'm interested in finding the induced surface charge densities on these planes, infinite grounded conducting planes. So that requires me that I should find my potential as a function of xy only. Okay. And I found that my potential as a function of xy is this, and it is also uh, giving me the right result because see, I can expect that my potential on this particular plane should be 0, and my potential on this particular plane should be 0. So whatever potential I wrote as a function of xy is giving me the right results for the boundary conditions. Is that clear? Next, I also wanted to calculate what is the induced surface charge density. So induced surface charge density comes out in this fashion. Is that clear?
Yes, sir.
Okay. Now, one needs to find what is the total charge induced, but the problem statement was given in the sense of in the terms of linear charge density. So it would be nice to find what is the total uh, linear charge density induced instead of finding total on the two planes. So one can understand that if I multiply sigma by the dx and dy and integrate this, I will get total charge Q. Okay. Then I will get total charge Q. Is that clear? Bharat, is that clear? Bharat, is that clear? So if I integrate this sigma into ds, then I will get total charge Q. Is that clear?
Yes, sir. मेरा डिस्कनेक्ट हो गया था सर लास्ट लाइन या फिर 1 मिनट में पूछा
हाँ,
मैंने.
वही सोच रहा था कि दो भरत कैसे आ गए, but understand the point that this is infinite line of charge. Okay, this is an infinite line of charge. So I can only take one differential element here. Is that clear? And if I take one differential element and if I multiply sigma into that differential element dx, I will get the dimensions of charge per unit length only. So I'll anyway get linear charge density. Is that clear or not clear?
Yes, sir. Clear, sir.
Okay. Now, on the surface of these two planes, I have this sigma. And if I want to find what is the total charge, linear charge density induced, what I can do, I can simply, let's say on x-axis, my x-axis is y equal to 0 plane. Okay. So the total charge induced charge density would at y equal to 0 would be equal to what? I can write it as sigma into dx. And from where to from 0 to infinity. Is that clear? And I can write
Yes,
it as
sir.
minus 4 lambda ये जो भी है क्या है ये सारा का सारा. I think there is a b and then I think there is a y. y भी था क्या यहाँ पे? एक बार पहले देख लेते हैं इस चीज को. x था शायद ना, 2 वाला ये था ना. 2 is y equal to 0 मतलब x, sorry my mistake. So this is x here, and then you should write y, and then I can write x minus a का square plus b का square, and then I can write x plus a का square plus b का square. Is that clear? ये कोई दिक्कत नहीं, और यहाँ dx लगा दी और यहाँ 0 से infinite लगा दी. कोई दिक्कत? This will give me total charge density induced on y equal to 0, that is x-axis. Or you can say on the plane which is parallel on the x-axis. So your lambda induced at y equal to 0, you will find it as minus. एक काम करते हैं, 0 से infinity है ना, तो इसको एक काम करते हैं, this lambda I'll take outside, तो life easy हो जाएगी मेरी, and this pi also I'll take outside, चलो life easy हो जाएगी मेरी. And what I'll do, this is 4abx. So if you remember from your childhood classes, x plus a का square plus b square minus x minus a का square plus b square. If I want to find, and here क्या है, यहाँ पे क्या, x minus a का square plus b square into x plus a का square plus b square. Is that clear? तो अगर तुम इसको घटाओगे तो b square से b square cancel हो जाएगा, and this will be but it will only give you some a only, no? It will not give you b. चलो जो भी है. So this will give you, so एक b बाहर कॉमन ले लेते हैं. Is that clear? ये चीज समझ में आई? देखो
Yes, sir. Yes, sir. Yes, sir.
this is 2x, this is minus 2x, तो plus 4ax हो जाएगा.
4a.
ठीक है, so I think this is quite clear. So I'll get what? I'll get minus lambda v upon pi, and this integration from 0 to infinity, this is 1 upon x minus a का square plus b का square dx, and plus, sorry, minus integration from 0 to infinity, this is dx upon x plus a का square plus b का square. Sorry, is that clear? ये चीज समझ में आई? And if I correctly remember, the formula for this is tan inverse b by, right? So it is 1 upon a. So here you have this 1 upon b, because instead of a you have this. This will be tan inverse of x minus a upon b, and then minus 1 upon b tan inverse of, this is how it is going to be, right? And this is from 0 to infinity. Is that clear?
Yes, sir.
Okay. So the total linear charge density induced on y equal to 0 plane, I think it should be this 1 upon b would cancel, and infinity pi by 2 minus pi by 2 would become 0, and 0, so negative would get absorbed, so this will become lambda upon pi, and this will be tan inverse of minus of a by b minus tan inverse of a by b. So I'll think it should be minus lambda upon pi tan inverse of a by b. Is that clear?
Yes, sir.
Sorry, 2b है ना, मतलब these two things. Okay, is that clear?
Yes, sir.
What would be sigma induced on x equal to 0 plane? The same steps you have to do, just try to find it. I'm writing the entire expression for you, minus 4 lambda a b y dy divided by, I think it will be y plus b ka square plus x square,
Yes,
a square, and then you have this y minus b ka square plus a square. You just try to find it. I'm giving you a minute. I think then we'll discuss. I'm giving you 1 minute. Just try to find this integration. The same steps that I did, you just repeat. Okay, just take 2 minutes and try to find it. Okay, so should I do it, or will you be able to do it? So I think I can expect the answer to be, because this is y by b upon a ना, तो ये सारे स्टेप तो सेम चलेंगे. I think this will be minus 2 lambda upon pi तक तो ठीक है. I think then you will get tan inverse of, because this will be y by b upon a ना, this will be b upon a. You find the integration because the same steps are going to come. Only difference is that this is 1 upon b. You here you get 1 upon a, and minus lambda b की जगह you will take
lambda
a कॉमन आउट ना, तो एक 1 upon a से कैंसिल हो जाएगा. दिस y upon y plus b upon b. मतलब समझ पा रहे हो ना, तो ये आ जाना चाहिए. इज दैट क्लियर?
yes sir.
So this would be your answer. अच्छा, one thing that I can one thing that we can think is, we can uh, promptly say that total linear charge density, totality means totality. Total linear charge density on this plane plus this plane, मतलब total on this plane plus this plane should be equals to minus lambda. ये चीज तो क्लियर है, क्योंकि if you had this infinite line
Yes,
of charge with lambda, total charge density induced on both of these planes, the total sum should come as minus lambda total. Okay, this is expected. This is expected that if you're placing a lambda here, and since these are conducting planes,